All right, in tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, we were in the process of making our lines more intuitive so we can perfectly generalize or separate our data without any mistakes. So, what we really want to be able to say, given this data, how can we generalize this as best as possible, is to come up with a line like this that seems like the intuitive line to draw. And the reason that it is intuitive is because it seems to be as far as possible from the X data points and the O data points. So that if we generalize a little bit and assume that maybe we have some points that are different from the input but still slightly further away, we can still say that something on the left, probably X data point, something on the right, probably O data point. And we can make those judgments that way. Now, this is the actual graph that we came up with. You can see our line separating our data points, our X's and our O's. So it's saying that something on the left side is probably going to be an X data point, and something on the right side is probably going to be an O data point. Remember, our X's stand for not rainy days, and our O's stand for rainy days. And that is what support vector machines are designed to do. They're designed to try and find what we call the maximum margin separator, where the maximum margin separator is just some boundary that maximizes the distance between the groups of points, rather than come up with some boundary that's very close to one set or the other, where in the case before, we wouldn't have cared. And that's just the definition of the maximum margin separator, a boundary that maximizes the distance between any of the data points. So as long as we're categorizing the input well, that seems all we need to do. The support vector machine will try and find its maximum margin separator, some way of trying to maximize that particular distance. And it does so by finding what we call the support vectors, which are the vectors that are closest to the line, and trying to maximize the distance between the line and those particular points. And it works that way in 2 dimensions. Now, it also works in higher dimensions, where we're not looking for some line that separates the 2 data points, but instead looking for what we generally call a hyperplane, some decision boundary, effectively, that separates one set of data from the other set of data. And this ability of support vector machines to work in higher dimensions actually has a number of applications as well. But one is that it helpfully deals with cases where data may not be linearly separable. Now, that's where we're going to stop tonight. We did do a lot more. We did a lot more graphs, but we will pick it up tomorrow because it was a long day, and I don't want to get too drawn out and long-winded. But yeah, I'm going to keep you guys posted every step of the way as usual. You already know this is the Python Papi. You guys stay Gucci.